Hello friends and welcome to another video lesson from DBOS Talks. If you haven't subscribed yet, please click subscribe and click the bell so that you can be notified of new uploads. This is the latest video in a playlist called Serious Fun with SQL, and here we'll be learning how to do data masking in using SQL, which is specifically using Oracle SQL. When we say data masking or masking data, it is just another way of saying data encryption. So sometimes sensitive data needs to be masked. For instance, developers, you mean programmers, need a development or test environment in a bank or in a company. I'm using the bank as a good example because it is one such institution or environment where data really needs to be kept so secure. Okay, so let's just say developers, programmers need a computing environment and they need to use data, realistic data, real data from the bank in order to do their work. But the problem is that in doing that, you will be exposing personal customer information to these programmers, to these developers. So this is where, this is one use case wherein we can do what we know as data masking. Okay, so like I said, customer information is sensitive. So to protect such information, we need to mask the data, such as names, for instance. And there could be other sensitive information, such as ID numbers, social security numbers, telephone numbers, addresses. But at the very basic, names are very important, that we must mask these data if they need, if they will be exposed or be viewed by people who are not on a need to know position. Okay, so again, to do that, we'll put into practice something that I've talked about in a previous video in this same playlist, which is doing encryption. I will post a link in the description below on a link to my video on encryption and decryption, which is very much related to what we're doing now. In fact, it is the same thing. But in this video, we'll be looking at a real world, practice, real use case in the industry. So using my simplified definition of encryption, let me just put it there. So encryption is the process of converting information into an unreadable format. This is just my very simplified definition. Okay, you have data that is in a readable format, such as this, the words you're seeing now, and then encryption is making this unreadable, or at least garbled, or at least something that won't make change. Okay, so let's look at some existing data. I have a table here called customer table, and let's look at the data in it. Okay, so it's customer data. A table consisting of 5 columns, 1, 2, 3, 4, 5, and a couple of rows. So as the name suggests, it contains customer information. Now let's imagine this is sensitive information, like customers of a bank, for instance, or any company for that matter. So in any case, customer information is sensitive because it is precious information gathered by a company, and it could be used by competitors to their own advantage, right? So this is one scenario wherein we need to mask the data in case some other people, like external vendors, developers, are trying to get access to this kind of information. So we'll do encryption. Okay, so to mask that, we'll use a built-in Oracle function called translate. Okay, translate. Again, I'll be posting the link to a previous related video in the description below. You can check that out. So here we're using an Oracle built-in function called translate. And although it's called translate, it doesn't necessarily translate something into another language. What it does is it is used for encryption. Okay, so translate has 3 parameters. I'll make it like this so it's more readable. So it has 3 parameters. The first one is the string to be encrypted. String in IT terms is a bunch of characters that go together as one. Okay, so string to be encrypted, in this case, it could be these surnames here. This is a string, this is a string, this is a string. Okay, string to be encrypted could be this. The next parameter is what you want to search, meaning what letter do you want to search? Let's say if it's a D, what will I replace it with? And then the third parameter is the letter that you will replace that search letter with, or that character with. Okay, so I can ignore this from dual thing. I'm just showing you the syntax of the translate function. Okay, it has three parameters. The string to be encrypted. Again, string is a bunch of characters that go together. Second parameter is the search character, the character you want to search. The third parameter is the character you want to replace it with. Okay, we will understand it better once you see the example. Now let's mask the data in this table. In this table, which is customer table that we have just queried, my intention is to show you that I'll be encrypting this column called surname, family name. So I will be encrypting these values so that they'll become unreadable. Okay. So instead of a select statement, what I'm gonna use is an update statement. Okay. And it is not an update for every record, but just a single update with no work condition. We can do that also, but here with no work condition, that means I will mask all the records surnames. Okay, so I can take out now, I can remove the translate because I was just showing you the syntax. So if you look here, this is not a select statement, it's an update statement, but it still has the syntax of the translate function in it, which is here. So it's an update statement, update, it's a keyword in SQL. It's a data manipulation language command, DML. Update is the table name, customer. Set is also a keyword. Surname is the column name that I wanted to update. This one I'm pointing at. So meaning I wanted to update this table, specifically this column called surname. And how is that? How am I going to update it? By using the translate command. So translate, the first parameter I'm supplying is the string that I want to encrypt, which is the value of the surname column, which is all the values in this column. Okay. And this is the search string that I was talking about, meaning for every character, I will do a one-to-one replacement. So right now I am highlighting letter A, meaning if Oracle finds a letter A, it will replace it with this character, equal sign. If it finds a B, it will replace it with this second character, a slash, and so on. The C with an @ sign. Okay, that's how it works. So although I'm using an update statement, it is incorporating an Oracle built-in function called translate, which will do the magic of encrypting this bunch of text into something unreadable. Okay, so I will execute this now. Remember that this will focus on this column called surname, and for every occurrence of a string, of a character, it will do a one-to-one replacement. Okay, so I will execute this now. I will do a control enter. And you can see that 4 rows have been updated. That's good, but I still need to do some kind of a save. It's called commit in SQL. So I click on this. I can either type a commit command with a semicolon, or I can also click on this button. It will do the same thing. Okay, so it committed already. I can take this out, and then I will verify. If you remember earlier, I did a query of the data, and you saw some family names there. Now I'll query the data, which is after I've done the encryption. Okay, so now I'll focus on the column called surname, and you can see now that the values in it are unreadable. They have been encrypted by the command which I have just shown you, this one, specifically with the use of the translate command. Okay, so we have updated the table customer, and zooming in on the column called surname, And how did it do the change? This is by the use of the translate command or translate function. Okay, so for each surname, it did this one-to-one encryption, translation, but encryption actually. So you can see that it's now in unreadable format. That is encryption for you. So this is a simplified example of data masking. How do you make this more complicated? It's a simple trick of putting a certain number of string characters in between each one of them. We could talk about this in some other video later on down the road. Like say, instead of being a one-to-one, meaning right now, if let's say if this family name, say the family name is Smith, for instance. If you wanted to make this a bit more difficult to crack, it shouldn't be a one-to-one encryption, meaning 5 characters here, 5 characters here. You can put something like 5 characters. Let's say it was encrypted as this. So to make this complicated, you will put a fixed number of characters in between these letters. Random. Okay, something like 9IJKH would be somewhere here in between, and also another string of 5 characters in between here, if you get the drift. So anyway, that is encryption, data masking. Now that we have seen this, let's look. This is useful now. You can share this data now with people that who are not, let's say, employees of a company, or people who don't have the privilege to be viewing this kind of information. Then you can now share this info because the data has been masked, and you just keep your masking script, which is in this case this little bit of code here, and you can use that to reverse it, to decrypt the data, to unmask it later on once if you need to. Okay, so we will do decryption. Okay, a bit of definition here. Again, you can refer to my previous video, which I have posted as a link in the description below. So let's talk about this decryption. Decryption is simply the opposite of encryption. Okay, it makes the text readable again. Okay, so that is decryption. That's what we're going to do, which is the reverse of masking. You can call it unmasking. I don't know what. Okay, so if you remember, I will put it back. So this was encryption. The decryption, as defined, is the reverse or the opposite of decryption. So what happens is that if you look at the second and third parameters, like I said, the translate command has 3 parameters to it. This, the string to be encrypted or decrypted, and then the second is the search, and the third is to replace it with. In decryption, the second and the third parameters have to be switched. They switch places. If you'll notice the A, B, C, D, etc., here's the second parameter. Here it becomes the third. And here the encrypted one is the third. Here is the second. Okay. Again, encryption is the opposite of decryption. So the second and third parameters get interchanged or switched. So now what I'm going to do is I'm going to run this short update statement to reverse the effect of the encryption here, of the masking, to unmask the masked data. Okay, now the data is like this. If you look at the surname, it's unreadable. So I will do unmasking by executing this update command. So that is done. 4 rows of data again. I can type commit, or I can just click on this button. Okay, so next is I will. So what it did is do a one-to-one decryption. If it sees an equal sign, it will replace it with A. If it sees a slash, it replaces it with B, and so on. So now we can verify the data if it has been successfully decrypted, meaning unmasked. Oh, and there you go. You can see we're back to normal. We're back to the original state of the surname values over there. They are now readable. So this is unmasked. This is decryption. Okay. So I hope you've learned something new from this bit of video. Again, I have posted the link to my original video related to this, which is about encryption, decryption, in this same playlist. But here we're looking at a real world scenario or use case of when we really can use this encryption decryption thing. This is, in this case, masking and unmasking sensitive data. Okay. If you haven't subscribed yet, I suggest click subscribe, click the bell, spread the word, share this with your friends, and thank you for watching, and I will see you in the next video.